Welcome to EDU World Space.
So in this question, we have to find the fraction of change in mass when an hydrogen atom makes a transition from n equals to 3 to n equals to 1. Let's first find the energy required for this transition. We will use equation 27.15b. It says that the energy associated with a level n is given by minus z square 13.6 electron volt over n square. For hydrogen atom, Z is equal to 1, so this will be simply 13.6 electron volt over n square. So the energy required for the transition from n equals to 3 to n equals to 1 will be, let's call this delta E, will be equal to E1 minus E3, and this will be equal to minus 13.6 electron volt over 1 square minus 13.6 electron volt over 3 square. Now we know that energy is given by mass times the square of speed of light. Now since c is a constant, delta E will be equal to delta mc square. This implies that delta m will be equal to delta E over c square. Now since we are told to find the amount of decrease, we will choose the opposite of the change to make the whole thing positive. So we need to find the fractional change, which is negative of delta m over m. So delta m is basically negative here, and since we have to find the amount, we are including the negative sign in delta m to make the whole thing positive. So this will be equal to then, so we use the value of delta m from here, and we get this to be negative of delta E over mc square, and we use the value of delta E from here. So this is a very big expression, so I'm just gonna write delta E, or I can solve it over here. So let's solve it. So this will be equal to negative of 13.6 electron volt 1 minus 1 over 9. So delta E will be equal to 13.6 electron volt times 8 over 9. So let's use this value here now. So negative of negative is positive, so it will be then electron volt times 8 over 9, and we have 1 over mc square. So mc square is 9.11 times 10 to the power. So mc square for the hydrogen atom is basically 939 times 10 to the power 6 electron volt. Now we can solve this for delta m, negative of delta m over m, and we get this fractional change to be equal to 1.29 times 10 to the power minus 8.